Okay, so I'm starting to record right now, so we have this recorded for the future. This is number 4 and 5 from the quiz. So this is the quiz on 6.1 and 6.2. If I start not, just chat me if you can't hear me or something. Okay, number 4. Here's the problem. Okay, can you all publicly chat if you know? Tell me what you call. Oh, question 15, got it. What do you call a situation where you have a fraction equal to a fraction? What do you call that kind of setup? Oh my goodness, Emily, excellente, and Aiden, and Jack, excellent. It's a proportion, and Nathan, excellent. Okay, if a fraction, which is it's what a ratio looks like. It's okay. It's what a ratio looks like. A ratio is two numbers compared through division, which is a fraction, right? Good. That's good, Mason. No, it's okay. Slow internet, I understand. A ratio equal to a ratio, which in math looks like a fraction equals a fraction, is a proportion. What do you know about proportions besides the fractions themselves are supposed to be equal? What else is equal? Good, Ryan and Sam. I know that was public, but Ryan and Sam have both told me the right answer. But tell me, what's our knowledge of the other thing that's equal in a proportion? Like the fraction is supposed to be equal to the other fraction. That's what the equal sign means, right? But what's the other thing that's equal? If you do what and what, they are equal. Good, Mason. Good, Aiden. That's the answer. Cross multiply. Good, Emily. 24x, which is 24 times x, is equal to 30 times 8, which is 240. Now, how is that helpful? Because you can set up an algebra problem, can't you? 24x equals 240. Now, you know what that is? An algebra problem that's only going to take one step to get x alone. What's the step? If x is being multiplied by 24, what do we need to do to get rid of multiplying by 24? Divide. Exactly, Jack and Aiden and Nathan and Sam. Yes, divide by 24. And what do we need to do to keep Mr. Equal Sign happy with us? Be fair and divide the other side by 24. Good, Aiden. And yes, Nathan, that's the answer. Good, Jack. Cool. So these 24 over 24 cancels it right down to 1x. 25, got it. I got 2 people that have asked for 25. Oh, that's it, Ryan. I see. Yes, I totally get that. You could see that. Okay. 240 divided by 24, guess what that is? Something divided by itself with an extra 0 on top. That would, instead of being a 1, that would be a 10, right? Okay, so Ryan points out, as probably other ones of you who got this right saw, if this fraction has to equal the other fraction, the 24 over 30, then if you can do 8 times 3 to get to 24, or 24 divided by 3 to get back to 8, that's the same relationship these have. Is that what you saw? It's basically reducing this one to get this one. 24 divided by 3 is 8. 30 divided by 3 is 10. If you saw that, exactly. So that said a couple. Ryan, L, Sam, you did it in your head. I'm sure others of you did. Totally fine. Totally fine. Yeah. Number 5, maybe not quite as easy to do in our head. Maybe. Has some decimals. Something over 80. Maybe if you move the decimals in your mind, you can see that it's a 7 over 8 relationship. Did anyone see that? But let's say you don't see that. When you see problem number 25, you still say to yourself, this is a proportion. Fraction equal to a fraction, and it's missing something. But if I cross multiply 4.8d and cross multiply the other way, which is 336, What do you mean, Mason? Say more. Then you can do an equal sign between them and solve for D. Get D alone by dividing both sides by 4.8. Exactly, Ben H. Mason, talk to me more. Is it the cross multiplying? Is that what you mean? And making them equal to each other and then solving for the variable? D equals, yes, this is the one. Yes, Mason, this is the one. Do you know why? 70. 70. If you use the calculator, you'll get 70. Or if you do by hand, 336 in the house, 4.8 outside the house, move the decimal over, meaning you actually have to make it like that, put the decimal above, and then start going. How many times does 48 go into 336? 7. It'll go perfectly. Subtract 0, bring down 0. So how many times does 48 go into 0? 0. Why do you have to have this space filled in? Because there's a decimal after it. So you have to, it's not 7, it's 7D. What do you mean? You mean in your head you could figure out it's... Oh, and I'm sorry, I wrote the problem down wrong. This is 80. Heavens. I was using my notes, so this is all correct because I was just jotting it. Does that make sense? So can you tell that 4.2 over 4.8 is like 42 over 48? And 48 divided by, 6? Yeah, 48 divided by 6 is 8. There's a relationship here. 48 divided by 6 is 8. 42 divided by 6 would be 7. If this is an 80, maybe the relatable 7 is 70. I don't know. Do you see the connection? You just have to be careful with all the extra zeros / decimals. Okay, does that help everybody? Let's go into your homework, which is 6.3, scales and scale drawings. No, 6.4, hello, right? No, 6.3, back. Scales and models. A scale tells you the relationship between the mini thing and the real thing, or the mini thing and the big thing. That's the relationship. If something else is asked about it, that same type of relationship is present, right? If we're talking about a map, 1 inch is 100 miles, then 3 inches is 300 miles. That's always a proportion. But I do think this homework is hard, not because it's terribly hard to set up a proportion maybe, but because you might be asking yourself, what did they want me to do? What are they asking? So let me help you. What are they asking? No, you didn't have any trouble with that. Here's why I think some people find that difficult, because the question of finding something, if they tell you the miniature information but not the real information, so you put an X and cross multiply and solve, that may not be that bad, but some of the questions ask you about scale factor, and that's a different question. And I talked about this in class, and some of you even took a screenshot, but the question of what's the scale factor means to just take the scale itself, like 1 inch is 3 feet, make everything into the same unit. 1 inch is 36 inches, and then reduce if you can. This one I made up doesn't reduce. Scale factor is a different question than like, here's the scale of the map, and what's the story if it's 3 inches on the map, what's the real life distance or something? So they ask you different types of questions. So I think the hardest thing is figuring out what did they want you to do or find. First question is number 6. What's the scale factor? Back to that scale factor question. Okay, so the first Number 5 got you the answer to the scale. The answer to number 5, so if you got that right, you realize that it's 1 inch to 5 feet. Perfect, Emily. Now, the scale factor, going back to what I just said right here, is for you to take that scale, get everything in the same unit, and reduce if possible. So what do we need to turn it into, inches or feet? What have I advised you to always do? Exactly, Emily, Jack, and Aiden, and Sam. Yes, go to the smaller measurement thing. Inches measure a smaller distance. Everything should go to inches. For every foot, there's 12 inches. So for 5 feet, there's 5 times 12 inches. Exactly, Nathan. Exactly, Aiden. So 1 inch stays the same, but we want to change 5 feet to 60 inches. Now we're talking inches to inches. And does it reduce? No, exactly, Emily. So you'd say 1 to 60. Do you know what that means? The real thing is 60 times larger than the mini. 60 to 1. Yes, 60 times bigger. Now, do you know why we need to switch it to the same unit to see that? Because if you looked at it here, you'd say, oh, it's 5 times bigger. If someone asks you, what's the actual factor between the big and the small? This is not true, is it? 1 to 5, or 5, the thing that's real is 5 times bigger? That's not true, because you're comparing feet to inches. You can't use that to tell the world the real thing is 60 times bigger than the miniature. You can only tell the scale factor by getting everything in the same unit. Yeah. It's complete. To say 5 times bigger is just wrong, right? That's why the scale factor question is, tell me the true relationship between the miniature thing and the big thing. The only way to be able to say out loud the big thing is 60 times larger is to be able to compare them in the same unit. Okay, next question, going in order. Someone asked about 15, 16, 17. Ooh, let's fly. We have a lot of questions. 15. Okay, the thing you had to use for 8 to 15 was a scale. I don't know if I'm typing. Okay, Ryan V. Yeah, and I am seeing public chats. Wonder if your private chats aren't working. So you want to go out and in? Good deal. Okay, the scale given to you for everything from 8 to 15 is a 1/2 inch to 3 feet. How many of you took my advice and used the scale as 0.5 inches to 3 feet if you're using a calculator? That was my, yeah, Emily, that was my suggestion, because if you're typing things into a calculator, you don't want to deal with a 1/2. You want to deal with a 0.5. Okay, so here's the story on 15. The 15 says that the cafeteria, okay, I spelled that wrong, is 8 1/4 inches on the drawing. What's it in real life? Yeah, didn't I tell you you could use a calculator? I feel like I said that more than once. You are welcome to use the calculator on these. Did that stress you? Would that have helped to use the calculator? Yeah, it's fine. Okay. As I advised you the other day, set up a proportion, because the relationship between the scale, 0.5 inches to 3 feet, is proportional to how the cafeteria would be, 8 1/4 inches to the unknown real life feet. All right. Okay, so you kept it, Ryan, you kept it with fractions. If I was using a calculator, I would turn that into a decimal. Either you know it's 0.25, or you do 1 divided by 4 and get 0.25. You learned how to change a fraction to a decimal in Chapter 4, 8.25. Now you have a problem that has decimals, but that's okay. How do you solve this? Yeah, I'd rather use decimals too, Nathan. How do you solve this? Cross multiply across that way. 3 times 8.25, 24.75. Does that sound right? 24.75 equals 0.5 times x, right? And then divide both sides by the 0.5. Then this on a calculator, 24.75 divided by 0.5 actually doubles it. 49.5 equals x. Did you half it? Someone who gave me 17 or something like that? Because 49.5 is correct. So do you know where you went wrong if you gave me 17.5? Did you try to do it in your head? Because you're so smart. Those two multiplied gives you 24.75. These two multiplied give you 0.5x. You divide by 0.5 on both sides. Dividing by a half is the same as multiplying by 2 over 1. Have you ever thought about that? Remember our fraction section? Dividing by a half is the same as multiplying by the half flipped over. So it shouldn't be that surprising that 24.75 divided by 0.5 in your calculator actually doubles the 24.75 if you think about what dividing by fractions actually is. Isn't that interesting? Okay, questions? I've got to keep moving fast because you asked a lot of questions. Okay, 16. Oh, refer to this whole thing. What's the scale factor? Okay, so all of it used the 0.5 inches to 3 feet. This is super interesting what I'm about to do. Okay. The scale factor, having a fraction within a fraction, is about to be something we clean up. Let's do this. 0.5 inches to how many inches in 3 feet? If we're turning everything to inches. Exactly, Nathan. So does everyone agree that turning, as I told you earlier, scale factor, good, Sam, you put everything in the same unit and then reduce if possible. Well, this is interesting because I wouldn't reduce this, but it's not a good, clean answer to have a decimal mixed into a fraction. Does anyone know what to do about it? How could we make this 0.5 into like a whole number? Exactly, Emily. I love it. Emily says, why don't we just double the top and bottom? 1 inch to 72. It is a fraction with a decimal mixed into it. So since the numerator is a fraction and we don't want to leave, generally speaking, we don't want to leave decimals in fractions or fractions mixed into fractions and call that our final answer. But why is it okay to double the top and bottom? Isn't 1 over 72 in essence the same as half over 36? If they are proportional, they are equal. If they are equal, they are the same basic number. 0.5 over 36 in my calculator, or divided by 36, gives me 0.0138888. If I actually divide this in my calculator, I get 0.0138 forever. If I divide this one, 1 divided by 72, I get, same thing, 0.0138888 forever. So if they are the same, this is a nicer looking answer, not leaving the decimal mixed into this fraction. So what are you going to do about it if you have a decimal mixed into a fraction? You have a couple of options, but basically if you will just multiply the top and the bottom, multiply them by the same thing, you will have an equivalent fraction that looks nicer. If it will, Jack. If you always multiply the top and the bottom by the same thing, the fraction you get will be equivalent. Why did Emily say double it? Why was doubling it the perfect thing to do to a 0.5? What did it turn a 0.5 into to double it? Or a half? It makes the half into one whole. Good, Aiden. What if it had been 0.25 over 10? And I said, let's make that not have a decimal in it. What would you want to multiply a 0.25 by? Exactly. Sam, Nathan, Aiden. Yeah, if we multiply a quarter by 4, don't you get one whole? So go ahead and do the same to the bottom to keep it proportional. 1/40th is a neater answer than a decimal mixed into the fraction. Does that make sense? You want to know another trick you could do? What if it was 0.8 over 13? Anyone have a clue what to do? What does this have to do with the answer, Ryan? The answer in the book is this, not this. And so I'm guessing some people were like, I got this and I don't know why this was the answer. It is because mathematically we don't leave decimals in fractions. We clean it up. And the beauty of fractions is as long as you multiply the top and the bottom by the same thing, you get an equivalent fraction that's prettier. Prettier fraction. Watch this. 0.8 over 13. Is there a nice easy thing that you can multiply that by? Like 2 or 4? You know what you can do? Multiply everything by 10. Oh, Aiden, yes, that's it. Yeah, multiplying it by 2 will get me 1.6. That doesn't fix it. Does that make sense? Multiplying a 0.8 by 2 doesn't give me a nice round number. But if I multiply by 10 on the top and bottom, do you know what that does? Makes my 0.8 an 8. Makes my 13 a 130. See, multiplying by 10 has that fun trick of just moving the decimal over. 0.8 times 10 is 8. 13 times 10 is 130. But, good, no, I gotcha. Good, Nathan. But it's as easy as like, oh, if I want to scoot the decimal over once in the numerator, I'll just scoot the decimal over once in the denominator and I'm all good. Now we're going to use that trick in our new lesson. So keep that in mind. If you ever have, like 0.7 over 2.3 and you're like, ugh, Miss Chrissy says don't leave the decimals in a fraction. Scoot that over 1, scoot that over 1. 7 over 23 is equal, or 0.7 over 23. If you have to scoot that over 1 to make that a nice 7, where's the decimal in 23? Right here, scooted over 1, you have to add a 0 to 30. See that fun trick? It's all good because, as we've been saying, it's proportional. If you do the same thing to the numerator and denominator of a fraction, you get an equivalent fraction. It's all proportional, meaning it's all equal. Okay, I hope that's helping people rolling along. 17. Oh, what's the scale factor if the scale is 8 inches to 1 foot? Okay, what should we do? If they say scale factor, everyone. Oh, wait, on this one? This one, Sam? In this one, if the decimal is here on the 0.7 but here on the 23, to get the 0.7 to be 7, you have to move it 1, so you have to be fair and do the same thing to the bottom, which means making 23 230. Because basically it's a times 10 on top and bottom. 0.7 times 10 to 7, 23 times 10 230. But it's as easy as move the decimal the same to the right, top and bottom. Okay, back to this. We always turn it into, yes, Aiden, inches. So, exactly, Emily. So 8 inches, good Ben, good Ryan, to 12 inches reduced just cleans it up to be what? They both divide by 4. 2 to 3. So what's the comparison? 2 to 3. The miniature is 2/3 of the large. Does that help, person who asked about 17? Notice every time it's a scale factor question, the word factor. Did I say good, Sam? Good, Nathan, for the final answer? Factor, scale factor, not scale, but scale factor. We're always making the scale information into the same units and possibly reducing if we can. Is everyone catching the difference now between scale and scale factor? It's different. 19. Insects. You have a picture of a honeybee. This is weird. I understand this one is yesterday's class. We had to talk about this quite a bit. In the illustration of a honeybee, the length of the honeybee is 4.8 centimeters in the drawing. The real honeybee length is 1.2 centimeters. What's the scale for the drawing? Okay, so first of all, how many of you looked at this and said it's a 4-to-1 relationship? 4 to 1. 4.8 over 1.2 is like 48 over 12, which is 4 to 1. Yes. So normally, yes, Aiden, that's the weird thing about this one. In this case, because an actual honeybee is so small, they have made the drawing larger so that you can see, I'm guessing, parts of a honeybee. Let's say it's a science book. So instead of a scale where the miniature thing is little and there's an actual big thing, in this case, the actual thing is so tiny, the drawing is large, so we can blow it up and see it better. So many people in yesterday's class said, why wasn't the scale 4 to 1 in the answer? Here's why. If I can hang with me on this, it's kind of hard to explain. Okay. In a drawing, think about the map scenario. In a map scenario, you want the map to be easy to manage, so you make the map be the 1 inch and the real life thing relate back to 1 inch on the map. So every inch on a map is 100 miles versus saying, 0.01 inches on a map equals 1 mile. Because it's hard to measure, you're using the map to figure out miles. Well, in this case, they want you to make the drawing information the nice round 1 unit so that you can work off of that to figure out, well, if the bee's antenna is, 1 centimeter, then the actual bee's antenna is 0.25 centimeters. They want things to relate back to the drawing. Therefore, we need to force the numerator to be 1 centimeter. And the question is, how many centimeters is the denominator? Exactly, Nathan. Now, don't worry, I'm not going to put something this, not that this is terribly complicated, but it's weird, and I wouldn't put anything like this on a test or quiz. Because as I said up here, the thing I thought was hard about this homework, some of it was what are they asking you to do? Not that you couldn't solve this if I set this up for you. See, if I set this up for you, hopefully, where did the 1 centimeter come from? Okay, so Ryan, what I'm saying is to find the scale to put in the science book on the drawing, to put over to the side of the drawing, for every blah blah in the drawing, the actual honeybee is blah blah. Does that make sense? This is what we know to be true. 4.8 centimeters of the long honeybee on the drawing is 1.2 centimeters of an actual honeybee. Sure, Jack. You want to, in the science book, let's say, make everything focused on the drawing and easy to measure off of the drawing and convert into real life. So we make everything focused on this scale for the drawing, easy to measure from the drawing. For every 1 centimeter on the drawing, relate that back to the honeybee. That's why we made this. And that's why I'm saying some of these questions, it was hard to determine what they wanted you to do. Therefore, I wouldn't put this on a test or a quiz to confuse you. But if I set this problem up for you, 4.8 over 1.2 equals 1 over x, could you solve it? What are you going to do? Yeah, cross multiply, cross multiply. 4.8x equals 1.2 times 1 is that, right? Divide both sides by 4.8, divide by 4.8. Hey, remember my trick? Remember my trick of moving the decimal over 1? Moving the decimal over 1? Isn't it 12/48 too? Which is 1/4. So our scale is 1 centimeter for the drawing equals 1/4 centimeter in real life. Or real B, yeah, real B. Or you could say 1 centimeter to 0.25, which is probably what the book said. Ah. Okay. Here's the thing. They want the drawing to be the basic measurement. The drawing will have on it every 1 centimeter on the drawing that we have for you of the honeybee is equal to 0.25 centimeters on a real honeybee. But it's hard, the part that you're finding, no, that's why I'm saying, I'm explaining to you why they would answer it this way instead of 4-to-1. They would say 1 to 1/4, which is the same relationship. 4/1 or 4-to-1 is the same as 1 over 0.25. It's the same relationship. The reason they made the 1 centimeter kind of the guiding point, which is what I'm trying to explain to you, but I don't expect you to have known, is that they want the drawing to be the thing you measure off of. So they want the drawing to be a nice round 1 centimeter. For every 1 centimeter, it's 0.25 on the real honeybee. 2 centimeters, it's 0.5 on the real honeybee. 3 centimeters, it's 0.75. Because imagine the scientist looking at the drawing, taking measurements, and needing to think about a real honeybee off of that. It's okay if you don't understand it. It's not going to be on the test, and we have a lot of questions to go through. But I do hope many people have sort of understood why. Okay, 26 through 28. So person who asked for 26 through 20. No. 4.8 is 1.2, which is the exact same as 1 is to 0.25. If I can go ahead and fill in the answer. 4-to-1, 4-to-1. The thing that I had to kind of tell you, because you may not have realized, is they wanted the 1 centimeter to be right here. Yeah, the relationship, so you're trying to relate these two as a ratio, and they aren't a ratio necessarily. This is the scale. This is a different scale. Both proportional fractions. I see what you're saying. Okay, number 26, person who asked for 26, 27, and 28. This is review of the same kind of stuff that was on your quiz. So if you couldn't do this, did you miss number 5 on your quiz? I can't remember who asked. No? Oh, okay. Well, interesting. So you struggled with 26, 27, 28? It's a proportion. So now that we've reviewed it, how do you think we should solve it? Fraction equal fraction, missing something in. Yep, exactly, Nathan. Person who asked about it, you tell me. Ben, exactly. But person who asked about it, tell me, how do you solve a proportion with something missing? If 2 fractions are equal, we know what is also equal. Remember this? Cross products, right? Nope, cross products. 20 times 15 is 300. n times 50, 50n. Remember what we do? Say, well, those are also equal. So I can put together an algebra problem where I solve for n. Divide by 50, divide by 50. 300 divided by 50 is 60? 6. 6. Yeah, good, Rhino. Does that make sense? Person who asked about this? Okay, does this refresh your memory? So interestingly enough, you made 100 on the quiz where you had to do 2 problems like this, and then when it's a review problem in the very next section, I'm guessing you forgot how to handle it? Correct? It's just you and me here. Okay, 75% of people would be exactly like that. $20 times 2.5. Wait, isn't 20 times 2.5 50? There isn't 20 times 2.5 though, it's 20 times 15. Okay, so one person is admitting what probably many of us feel, which is I can do a section when it's the thing I just learned, and then 3 days later I forget. How many of you would say that's true for you? Boom, it's on a review 2 lessons later and you forget. Okay, so there are some things that I would say, that's not so bad. This isn't that. Realizing that a proportion, which is a fraction and a fraction with an equal sign between them, always has equal cross products. I agree, Nathan. Is a skill you need to take with you. Is a skill, is knowledge that you need to keep. How are you going to keep it? I love what Nathan just said. You have to practice it enough that it sticks. When you see this in a month on a review section of a homework, will you still say to yourself, self, I see fraction. I see fraction. I see equal sign. That's a proportion. Exactly, Jack. You have to talk to yourself and say, self, you can remember this. Fraction, equal sign, fraction has another important thing. What is that important thing I'm supposed to remember? Oh, yeah. If I cross multiply that way, 32x, it's equal to cross multiplying that way. I don't know 14 times 8 off the top of my head. So I grab my calculator. It's okay with me. 112. And once I do that, hopefully, I have also learned this. Anytime I have a variable in a problem, I can use algebra and I can say, self, how do you get x alone? Self, undo the times 32 with a divided by 32. What else do I need to remember, self? Make him equal sign be happy by dividing other side by 32. Gotcha. Hey, Riley. Does that make sense? How much of math is you having to have remembered an old lesson? All of it. Right? I mean, at some point, you learned it was the first day you learned how to add. And that was a new lesson to you. Now, how often are we adding? Constantly. At some point, it was your first day to multiply. And you use it all the time. Well, guess what? Now algebra is supposed to be, like algebra is get the x alone by undoing the math and being fair to the equal sign. That's supposed to be a skill in your toolbox now. And I'm telling you today, adding that proportions have equal cross products needs to also be added to your toolbox. Okay? But person who asked about 26, 27, 28, do you understand now? Cross multiply, solve. I only say that because we are definitely tight on time. Okay. Okay, 24, 25. Person who asked about 24 and 25C, what's your worst? What's your worst problem? I need you to pick one for me because we really need to switch to the new. Okay, 25. We need to switch to the new lesson 4 minutes ago. Okay, 2 rectangles. Here's what you learn from number 25. If you have, well, let's just 2 centimeters. I'm going to go as fast as I can. 2 centimeters tall, 5 centimeters long, and there's a double-sized rectangle, 4 to 10. As you do number 25, it asks you what's the perimeter. What's the distance around? 2, 5, 2, 5, right? What's the perimeter? 10, 11, 12, 13, 14. What's the perimeter of this one? 4, 10, 4, 10, which is 28, right? That's perimeter. First thing they ask is perimeter. Then they ask you area. How do you find area? Length times width, 10. Length times width, 40. Then they ask you, what's the, basically the ratio, perimeter to perimeter? Okay, if you compare perimeter to perimeter, isn't it 14 over 28? What does that reduce to? 1 to 2, correct? 1 to 2, correct? 14 over 28 is 1 over 2. Okay, you know what that tells me? If you double the size, like double the length, double the width, so you double the rectangle, your perimeter is going to be double the first one. The bigger one is going to be double the first perimeter. Does that make sense? Okay, then it says write a ratio for the area. A ratio is just comparing two numbers through division, 10 over 40. What's that reduced to? 1 to 4. Yes, Aiden. Okay, yes, Sam. What does that tell you about doubling the rectangle? The area quadruples, doesn't it? The second one is 4 times the area of the first one. That's what this says to me. Do you follow that? Person who asked about 25? Everyone, but particularly. Perimeter doubles if you double the size of the rectangle, but area goes up by 4. You can tell 10 to 40, that's a times 4 relationship. Now, they give you a second scenario where you have a 3 by 5 rectangle and a 6 by 10. And it asks you to make a guess if this one has a perimeter of 5, 10, 16. From this information, make a guess at what this one's perimeter would be without actually doing the math. Well, what does this tell you that perimeters do when you double the rectangle? If the perimeter of this doubled rectangle went from 14 to 28, or 1 to 2, doubled. Exactly, Sam, Emily. You see it? Doubling this rectangle should also double the perimeter. Whoops, 32. But what do you expect it to do to the area? If the area of this one, 5 times 3 is 15, what do you expect the area of the doubled rectangle to be based on that? Look at this. Look what the area did. Area didn't double. It went up times 4. 1 to 4. Yep, Nathan? You see it? Our experimental rectangles showed us that perimeter doubles when you double the rectangle size, but area quadruples or goes up by 4, 10 to 40. So what do you expect 15 to turn into? Besides Nathan, can someone else tell me? Good, Emily. Good, Aiden. 60. Good, Sam. 60. Because in our first doubled sized rectangle, the area went up from 10 to 40, giving us a ratio of 1 to 4. When you double the size of the rectangle, the area seems to quadruple. So you could expect the same thing to happen here. 5 times 3, that small one has an area of 15, so this one is a double size, pretend, if I had drawn well, but you can expect the area to go up by 4. Now, again, I'm not going to ask you something like this one either. The idea is, could you look at a scenario 1, and kind of learn how the relationships of perimeter and area relate in ratio form, and then use it to conjecture, which means make an educated guess of how this other doubled rectangle is going to act, perimeter and area. That's what that was. Okay. Does that help it a little bit? Sort of open your eyes? 35. I'm sorry we're in a rush, but thankfully it's all recorded, so if you'd like to go back and watch it again, if you asked about it, I do not want to have us in trouble having not covered our new lesson, okay? This says find the product or quotient. This is a quotient, right? Because it's a fraction bar. But because it's a fraction bar, you can also keep it, think about it as a fraction, and just reduce it. And that's what we need to do here. 24 over 18 doesn't reduce to a perfect, 24 divided by 18 isn't a perfect answer, right? So, can we reduce 24 and 18? Do they both have a common factor? Don't they both divide by 6? 24 divided by 6, 4. 18 divided by 6, 3. Yeah, good. Okay, now let's look at our m's. This is m 5 times on top, right? M multiplied. That's power of 5. This is m, right? Can't an m over an m cancel to 1? And another m over an m cancel to 1, leaving how many m's multiplied on top? M to the third. This is the simplest way. Gotcha. Simplest way to write this original fraction. Do you remember our trick that we learned in chapter, I forget, 3, 4 maybe? If you have m to the 5th divided by m to the 2nd, since the m's, the bases are the same, can't you just do 5 minus 2 equals 3? If it's division, you can subtract. Yeah, gotcha, Nathan, Ben, Aiden. Yeah, you see that? Subtract them. What is that? What is the 5 minus 3? Why does 5 minus 2 equals 3? Why does that work? Because it basically is saying these two are going to cancel with these two. 2 of the 5 and 2 of the 2 are going to cancel out, leaving only 3 m's multiplied in the numerator. It is. I love the shortcut. Okay, now we have got to move on to the new lesson as fast as possible. So if you need to rewatch those, the recording is there, and I will get it up ASAP this afternoon because yesterday's class didn't ask all of those questions. Today, folks, we are talking about something, we're adding to something that we're building on something, I guess I would say, that we've done before. How do you turn a fraction into a decimal? 1 over 2 is what decimal? Divide. Exactly. Divide with the cowboy. Cowboy in the house, horse outside the house. Divide. Top by bottom, you get 0.5. How do you turn that decimal back into a fraction? You'd put 5 over 10, not 0.5, but 5, the number over the place value. Remember this? Number over place value. And then what is 5 over 10 reduced to? A half. We learned this at the beginning of chapter 4, how to go back and forth. What's the only ones that you don't put over like 10, 100, 1,000? The special ones that repeat. What do you put 0.3 repeating over? Do you put it over 10? No, you use nines. How many things are repeating? 1, so you put 3 over 1, 9. What would you put 0.21 repeating over? 1, 9? Exactly, Jack. 99. Good, Sam, because since it's repeating, you use nines as many as there are place values of the repeating number. 21 over 99, which reduces, right? 1/3, 7/11. Remember that? Special, how to handle repeating fractions, repeating decimals going to fraction. Okay. Today we're adding in how to change both back and forth to percents. Ready? I'm sure you've worked with percents before. Am I right? Goodness, I hope so. What is a percent? 6-4. A percent, by definition, is a part of 100. Exactly. In fact, it's actually a ratio. Here's what I mean by that. If I say 8% to you, this percent symbol might as well be saying put the number over 100. It is part of 100. 8 out of 100. So how would you change 8% to a fraction? Pretty straightforward. 8 over 100. And then do you think you reduce it? If you can, sure. They both divide by 4. 2 over 25, and that's as good as it gets, right? 8 divided by 4 is 2, 100 divided by 4 is 25. That doesn't reduce anymore. Well, look, we're already 1/4 into our lesson, because what did I just show you how to do? Go from a percent to a fraction. How do you do that? Number over 100. Does that make sense? I want you to start thinking, when you see a percent symbol, I want you to say to yourself, self, so we do a lot of talking to ourselves in this class, Nathan. We say self, that's the same as saying 8's supposed to be part of 100, or 8 is part of 100, or 8 is over 100, right? Does that seem easy enough? If you're trying to change a percent to a fraction, you put it over 100 and reduce it. Let's see if we can possibly make that more complicated, math book. Okay, so this seems easy. Example 1A, 45%. The directions say, please change the percent to a fraction. What do you say to yourself? Of course the book can, right, Ryan? Yes, it gets harder. Exactly, Sam. The book's going to throw a little weird stuff into it. It's not going to make it negative. You know what it's going to do? Aiden, throw decimals and fractions into the overall fraction. But that's why I spent a little time on our homework actually telling you how to handle that. Okay, 45% as a fraction is exactly, Emily, 45 out of 100. Does that reduce? They at least are divisible by 5, correct? 45 divided by 5 is 9. 100 divided by 5 is 20. Does that reduce anymore? Nope. Check-a-rooney. Hey, this isn't that bad. Math book, 120% as a fraction. It is, the percent is yelling at us, this is part of 100. 120 over 100, divide it by tens. 12 over 10, divide it by 2, 6 over 5. Sure, you could leave it like that, or you could call it 1 1/5. Either way, check, check. Both of these are awesome. Okay, let's see. Here they go. Trying to throw us off, but we are not afraid. We can handle this. 0.5%. This is still saying what in your mind? This 0.5 could be put over 100. It's part of 100. That's what it's telling you. So you say, okay, 0.5 over 100. But what did I say earlier about leaving decimals mixed into fractions? Oh, we should double it. I agree. You want to do that, Aiden? It's a big no. Exactly, Jack. Don't leave this. So there's a couple ways we could handle this. We learned them a minute ago. You could either double it, times 2 times 2. Turn this into 1. 0.5 times 2 is 1 over 200. Check-a-rooney. Or imagine it hadn't have been one easy to double, which it is. But remember my other trick I told you? Move that over 1 and move that over 1. If it had been something else besides a 0.5, remember you can just move the decimal over to get rid of it, because it is exactly, Nathan, it's a times 10. 5 over 1,000, but that one needs to reduce. Guess what it reduces to? That. Of course, Nathan. Exactly, because it is 1 over 200. Because 0.5 as a percent as a fraction will eventually, you can clean it up to get to 1/200ths. Does that make sense that half of a percent isn't 1/100? 1% would be 1/100. So half a percent must be 1 out of 200. Does anyone follow that logic? How do you feel about those? Not so bad? Okay, a good from a Nathan. Doesn't seem so bad, says Jack. Sam, Emily's fine. Everyone else? What are you going to do about a decimal in a fraction? Is it that it's not time to go home? No. You can move the decimal over like I did here, or you can figure out what to multiply the top and bottom by to make the fraction go bye-bye. Like 0.5 doubled is perfect. 0.25 times 4 is perfect. But D, example 1D. 83 1/3%. Okay. This is telling you to put this over 100 if you have to turn it from percent to fraction, right? So you're like, okay, 83 1/3 out of 100 is what that percent is. Can I point out something? When you put the over 100, you no longer write the percent symbol. Why? Because these are equivalent. You either have a percent symbol or you have over 100, never both. Exactly. They're switching back and forth between the form of it where you write a percent symbol and the form of it where you write over 100. If you try to leave the percent on it, then this whole thing's supposed to be over another 100. Do you see the problem with that? You either have a percent on it, no divided by 100, or you have it divided by 100, no percent. Both mean over 100, but you can't pile them on top of each other. Okay. Is 83 1/3 going to be easy to turn into a whole number, in your opinion? If you turn it into a decimal and try to move the decimal over, does anyone remember what 1/3 is as a decimal? 0.3 forever. 83 1/3 is 0.3 forever. Do you know the problem with the 0.3 forever? Is that you can't do our fun little trick that I showed you right here of moving the decimal all the way to the right and then doing the same to the bottom, because there is no end. How would you know where to stop? You'd have to go on forever, therefore you'd have to move this over forever, therefore you'd be spending the rest of your life moving the decimal over forever. So that's not going to work. What about this? What about good old division? Since turning it into a decimal, Sam, okay, interesting question. This wasn't what is 0.3 turned into a fraction. That's not what this question was. Does that make sense? You're right, you would put it 3 over 9. This question was not that at all. This question was, I'm telling you I've got 83 1/3%, which is 83 1/3 over 100, and I want you to clean it up, which means let's not have a fraction mixed in. To try to turn that fraction to a decimal would give you 0.3 forever, which means you would have to spend forever moving the decimal over in the top and bottom trying to clean it, and it wouldn't work. You'd spend forever doing it, so that's not an option. But since a fraction bar means division, let's see if you know how to work this problem. It's not my favorite problem, but do you know how to work fraction division problems? You do. You learned it, or we reviewed it, I should say, in Chapter 4. Do you remember what division actually is? Multiply by the what? Multiply by the reciprocal. Flip that over. 100 over 1, flip it. Do you remember that? We don't divide fractions, we multiply by the reciprocal, or the flip, or the multiplicative inverse. Do you remember what else we do in fraction multiplication and division? We turn everything into an improper fraction using my favorite, the plus multiply, which I call the TX, the Texas rule, the Texas trick. 83 times 3 happens to be 249, plus 1 happens to be 250 over 3. You follow that? I am only resorting to having to actually do fraction division because my other plans aren't working, my other shortcuts. And it's because that isn't a pretty decimal. Exactly, Ryan. So if instead of, you could cancel 250 and 100, or you could just go ahead and say, okay, this is 250 over 300 and start reducing that. Now, what goes into both of those? Divide them both by 10. You can immediately do 25 over 30, right? And then break that down a bit more. Divide them both by 5. 5 over 6. Is that good? You're right, Ryanel. That is the answer. Clean, clean, jelly bean. Okay. How do you feel about turning percents into fractions? Let's go back to my guiding page. Where is it? Okay, what are we going to do? Percent to fraction, you're going to put your number over 100 and you're going to clean it up, reduce it. Don't leave fractions mixed into it. Don't leave decimals mixed into it. Do some of our strategies to make it look pretty. Okay, now we need to figure out what to do back that way. What if you have a fraction that's supposed to be a percent? Hello, new paper. Okay. Well, in example 2, if you have a fraction already and you want to turn it into a percent, let's say the fraction is, oh, sure, you know what? Not yet, Aiden. Or this one? You want that one screenshotted? In a minute, I'm going to finish up that main screen that tells you which to do either direction. Then you can everyone might want to screenshot that or make notes on it or of it. Okay, good? Okay. Okay, what if you have the fraction 4/5? How can you tell what it is as a percent? Any ideas? 4/5 switched into a part of 100. Oh, that'll do it. That's going to do it, Nathan. The setup of it that helped Nathan do that. Exactly, Sam. That's the answer. The setup of it is going to be, your best bet is going to be to make a proportion. If a percent is part of 100, then you want 4/5 to turn into part of 100. This will be the percent answer. Remember what I said? The number over 100 is the percent. What have I created here? 4/5 has to be a part of 100. So that is That means 4/5 has to be equal to a part of 100. Whatever that part of 100 is, that's the percent that 4/5 is. So you set up a proportion, cross multiply, 5x equals 400 divided by 5 divided by 5, x equals 80. Does it make sense that 80 out of 100 and 4/5 are equivalent? So Nathan said early on, I can see that you can do 5 times 20, get 100, so 4 times 20, get 80. Now what's the answer, 80 or 80 over 100 when they say turn the fraction into a percent? Just the 80 or 80 over 100? Okay, go back to what I said right here. Wait, where did I say it? I don't know where I said it. Remember where I said, oh, I erased it. The percent form of a number doesn't have the over 100. What does it have instead? The percent symbol. So does that make sense? So since the question was turn this fraction into percent, you don't put 80 over 100. 80 over 100 is the fractional version of 80%. But they didn't say, I want the fractional version. They said, I want the percent version, which means you put the 80 with the percent symbol. Does that make sense? Okay. Ryan says you could do 4 divided by 5. Ryan, what does 4 divided by 5 give you? 0.8. How do you know that's 80%, Ryan? Do you think it through like this? 8/10, which is 80/100ths. Therefore, the 80 is the percent because it's 80 out of 100. You add a 0, but you also, Ryan, you know what you're doing in your head? You're moving the decimal. You added a 0 and you moved the decimal. So you have some knowledge that not everyone would necessarily have. Yeah, 0.8 is 80%. We're going to do that in a minute. And then this would have been a way that anyone could do it. You could divide it, get it in its decimal form, and convert it to its percent form. In a minute, that's this part. This percent to decimal and decimal to percent that we haven't done yet. But we're about to add that to our big triangle of information. Okay, so fractions to percents, the red line, what are we going to do? Fraction equals the percent over 100. You're going to set up a proportion. You're going to put the fraction on one side equals the unknown amount of percent over 100. Solve for the question percent. Yeah, that would work. That works. Does everyone understand that? If you're going fraction to percent, that's why I have it red, you can set this proportion up. Fraction equals percent over 100, just like I did. Ooh, right there. Let me do one more. Example 2b. If you're supposed to turn 9/4 into a percent, the question is, what is equal to 9/4 as a part of 100? This answer will be the percent answer. How do you solve it? Cross multiply. Exactly. That's it, Nathan. Okay, 4x on one side equals 900. Divide both sides by 4. X equals 225. You can put a percent because that's what we found, the part over 100. 225 is what we found. X equals 225. Therefore, 225 gets to have a percent symbol. Now, is it logical to you that 225 over 100 is equivalent to 9 over 4? See how big 225 is compared to 100? Isn't that a lot like 9 being more than double 4? Do you see what I'm saying? 9 is more than 8, which is more than double 4. Therefore, 225 is more than double 100. That's a logical. Oh, it doesn't matter. Yeah, you could have gotten it, Sam. Depending on how you wrote this right here, like you could have written 900 equals 4x divided by 4 divided by 4. Then you'd get 225% equals x. That's, both of those are the same. Yeah, good question. You still have gotten that x equals 225. Okay, you ready for the super fast info about how to do this? I'm sorry, Jack. You're right, Jack. Did I say Sam? I meant Jack, sorry. How do you go between decimals and percents? I call it the Dr. Pepper rule. Okay, there's your screenshot if you want it real fast before you go. And then I'm going to explain it. I'll explain the Dr. Pepper rule in a minute, but now this page is written on, completely done. If you'd like to screenshot it. Is this clear? Number over place value. I should have kept all the numbers the same. I mean, all the colors the same. Dr. Pepper, decimal to percent, percent to decimal. See how the purple has arrows on both sides? That's because it works both directions. And then remember that this is its own special little world of repeating decimals. Or Dude Perfect. Or I have a guy named Dylan Pathio in my other class, and he made the whole thing his initials. But I was like, well, Dylan, people in this class will remember you because he's sort of our class clown. But I said everyone in the whole of the world will remember Dr. Pepper. Here's what Dr. Pepper is all about. It's really not about Dr. Pepper at all. It's about the fact that when you're going between decimals and percents, think about the problem and the way, was it Ryan? Okay, bye, Mason. The way Ryan said, let's just change 4/5 to 0.8. And he knew that 0.8 as a decimal number is 80 as a percent. Do you see what the difference is between 0.8 and 80? Decimal point, see or where the decimal point is? It's 2 places that way. Or if you were trying to go back, you'd have to say you got to go to 2 places that way. To go between decimals and percent, it's all about moving the actual decimal point 2 places left or right. But sometimes we forget which way it's supposed to go. The Dr. Pepper rule helps us remember. Here's what I mean. If you're going decimal to percent, jot down DP on your paper and say to yourself, if I'm starting at decimal, put your pencil by the D and say to get to a percent, I've got to go 2 places right. Does that work with what Ryan did with the 0.8? If you start with a decimal and you're trying to get to a percent, if you jot down DP and say, okay, I got to go 2 places right, then go to your actual number, put your pencil on the decimal and go 2 places right. Don't you get the percent? And then you add the percent symbol. You say 80%. But if the question is, what is 35% switched back to its decimal form? The DP, you jot down DP on your paper and you say, okay, I'm starting at percent. Put your pencil by the P and say, I'm trying to move it to a decimal. That's a 2 move to the left. So I'm going to do the same thing to the 35%. Where's the decimal in the number 35? Here. Put your pencil there, go 2 places that way. You say, okay, the decimal form of 35% is 0.35, no percent symbol. Percent, no percent. When you're going back to the decimal form, there's no percent symbol. Now, let me point out one thing that people find confusing. The decimal and percent form are basically just no percent symbol and percent symbol, and you move the decimal. It does not mean that there are not decimals in percent numbers. As we have seen from our other examples, yes, there can be, where's that example? Look, there is a decimal in a percent with a percent. Of course, decimals are in every number that we ever write. So the decimal form just means no percent symbol. Gotcha, Jake. Okay, let me just do a couple of these. If you've got to go, I totally understand. Use this as a reminder. The DP reminds you which way to move your decimal. If you're percent to decimal, you're going doop doop left. If you're decimal percent, you're going doop doop right. Does that make sense? Let me just grab a few examples. Here's example 3B. Oh, we already did it, hello. Well, something like it. Let's not do that one. What about example 3C? What's 375 turned into a decimal, as in no percent symbol, but not a fraction? You would, hopefully you have that DP in your head and you say, okay, if I'm starting at percent, put my pencil by the P. This is a reminder to go 2 places left. Look at 375. Where's the decimal? At the end. Go 2 places left. That's the new decimal. 375% is actually 3.75 with no percent symbol. Does everyone see how to use the DP? Example, so I say Dr. Pepper because it helps you remember not to put PD. Does that make sense? But if you're going between decimal and percent, if you write DP, it's just a quick reminder of left, right. I know, isn't it great? Versus just memorizing. It's hard to memorize. It's easy to have a trick. Okay, so look at example 4A. This is 0.35, and it says, please make it into a percent. So you jot down DP somewhere on the side of your paper, and you say, I'm starting with the decimal form, no percent. I'm going to go 2 places right, and that will get me a percent. Here's the decimal in my 0.35. I'm going to go 2 places right, 3, 5, add the percent symbol. Exactly. Good, Nathan. Everyone seeing the beauty of the DP? Just as a reminder. Here's example 4C, and then I've got to let y'all go because Algebra 1's going to be like, where is she? Okay. See, it's in the decimal form, and the directions say change it to a percent. So you say, okay, DP, from decimal to percent to right. That's how easy it is. It is that easy. Then in your actual number, put your pencil on the percent and do the same to right move. Your pencil on the decimal. 0.7, add the percent symbol back in. You see what I mean on C, that there are decimals? Yeah, there are decimals in all numbers. The decimal form of a number doesn't mean it's the only time you can write a decimal. It just means it doesn't have the percent symbol in it. Yes, so 0.007 is still a 0.7 with the percent symbol added onto it. It still has a decimal in it because the 2 moves put it in front of the 7. But since you moved it twice from D to P, you can go ahead and add that percent symbol back in. Okay, see the DP helpfulness? Okay, let me go back to my big picture. See why you can go both ways? The purple arrow has an arrow on both sides. The Dr. Pepper rule tells you 2 moves. Hold on. I probably should have said this if you wanted to redo it. 2 moves of decimal. And this tells you which direction. DP tells you whether to go right or left as a trick. Not mathematically in any math book. It's a trick. Just a reminder. Okay? Okay. If you feel good, you are free to go. I have to log off in 30 seconds, so screenshot this again if you want to. Bye. Toodles. Thank you. Have fun with the Dr. Pepper. Okay, I gotta go. Are y'all okay? Who are still here?